In this class we are going to discuss about 3 to 8 decoder design. So, as we discussed about decoders, that is decoders are the logic circuits which will decode n inputs into 2 power n outputs. So, here in 3 to 8 decoder n is equal to 3 and 2 power n is equal to 8. 2 power n means 2 cube means 8. So, that is 3 to 8 decoder. That means 3 to 8 decoder is having 3 inputs and 8 outputs. How we are getting 8 outputs means, so as inputs are 3, you are having 2 cube outputs according to the decoder theory. So, that 2 cube is nothing but 8. So, now while designing this decoder 3 to 8 decoder, you need to take the truth table first. So, truth table for required functionality. How we are designing the truth table for decoder means, so wherever you are having the particular input value, that port you are activating at 2 power n. So, here you can observe this is, you can treat as 2 power 0 place, 2 power 1 place, 2 square place, 2 cube place, 2 power 4 place and 2 power 5 place. So, 2 power 6 place and 2 power 7 place. So, you can treat like 2 power places. So, where 2 power 0 is nothing but here n is equivalent to 0. In place of 2 power 1 n is equivalent to 1. So, in place of 2 square n is equivalent to 2 like that. So, here when input, that means n is equivalent to 0, when input is equivalent to 0, you need to enable at 2 power 0 place. So, that you enable 2 power 0 place. So, when n is equal to 1 or input is equal to 1, you need to enable place at 2 power 1. So, this place you need to enable. So, remaining places you need to disable. So, here when 0 1 0 is there, so you need to write 1 here. So, like this you need to enable the corresponding powers, 2 powers. That means, for example, here the value is 7, you need to enable 2 power 7 place, remaining places you need to disable. Apart from this, you need to see for enable input for a decoder. This is very important. So, in gate like exams they may give like this. So, for a decoder the input is 111. What is the output when enable is equivalent to 0? Then definitely the options contains 1 and 6 zeros or 7 zeros and like that, and all zeros like that they will give. How we need to examine that question is, how we need to come to a decision that is based on enable line. If enable line is equivalent to 0 without knowing inputs, without having reference of inputs, your output is going to pull down to 0. So, here in that case, so even though your input is 111, you are not getting this, you are just getting this, because enable equal to 0 without knowing this. These may be ones or zeros or any data, you are getting 0 only whenever enable is equivalent to 0. So, all these conditions occurs when decoder is enabled, that means enable is equal to 1. So, okay, we will design the circuit now. So, here in combinational design steps we are writing inputs and we are writing outputs what we need to get, but we are taking the K maps when we are having multiple number of ones in each column, but here we are having single one. So, no need to take K map. So, here you can directly write the equation for each and every digit of decoder output. See, here I am writing y7, equation for y7, y7 is equivalent to 1 when we are having all ones. So, that means you can write as A, B, C. So, like that y6. So, y6 is 1 at 110, that means A, B, C bar. So, you can write A, B, C bar. So, like that y5, for y5, so you are having 1 at 101. So, that means A, B bar, C. So, y4 is 1 at 100. So, that means A, B bar, C bar. y3 is equivalent to 1 at 011. So, you can observe y3 is 1 at 011, that means A bar, B, C. A bar B C, and y2 is equivalent to 1 at 2 place, that means 0 1 0. So, A bar B C bar, this is 0 1 0. So, y1 is equivalent to 1 at 001 place, 001 means A bar B bar C. So, finally, y0 is equivalent to 1 when all zeros are there, that means A bar B bar C bar. Now, this is the time to draw the logic circuit for 3 to 8 decoder. So, in all combinational circuit design, first of all we are taking the truth table with inputs and outputs. For each output column we are making K map, or we are directly writing the expressions if single one is available. After getting expressions for the output variables, we are going to draw the logic diagrams. These are the steps we are following. So, here I am going to draw my logic diagram. So, logic diagram of 3 to 8 decoder I am going to take here. So, in this logic diagram, here I am having 3 variables A, B, C and their complements. So, initially normal variables I am taking with blue line, that is A, B, C I am considering with blue color, and their complements I am representing with red color. So, here that means A bar I am representing like this. So, this you just treat like A bar. So, this you just treat like B bar. If this blue line represents B, this red line of this with NOT gate represents B bar, and here I am taking C bar. So, here these lines I am representing like A, B, C, and these corresponding red lines represents A bar, B bar, C bar. Now, to get y7 you need to multiply all A, B, C. So, A into B into C you need to take in multiplication with the help of an AND gate. So, you are getting y7. Now, to get y6 you need to multiply A and B and C bar. C bar means here, from here you need to take C bar. So, this is another AND gate. So, y6 you are getting here. So, to get y5 you need to take A, B bar, C. So, here A, B bar means from complement, C means from normal line. So, you need to consider another AND gate. This is y5, and for y4, so for y4 what you need to take is A, B bar, C bar. So, here is A and B bar and C bar. So, you just consider a AND gate. So, here this is y4. So, y3 is nothing but A bar, B, C. So, here this is A bar. So, B into C will provide you y3. Multiplication of all these 3 with AND gate provide you y3. So, in the similar way y2 is A bar, B, C bar. So, A bar is taken from complement A bar, B. So, here B and C bar. So, this is taken to AND gate and it is providing y2, and I am just extending these lines to take remaining. So, here we need remaining y1 and y0, for that I am extending these lines. So, here for y1 you need to consider A bar and B bar. So, B bar is here and C. C means from here you need to consider another AND gate, and this AND gate output is your y1. Finally, y0 is, so all complements are multiplied together. So, here this is nothing but your y0. This is y0. So, now apart from this you need an enable line always connected with this. So, I am just representing with the black. So, here this is, you just treat like enable line. So, this is enable line. So, you need to connect always for each and every AND gate like this. So, I am just connecting this enable line for each and every AND gate. Why? Because for example, if this enable is equivalent to 1 for this AND gates, that AND gates outputs are going to depend upon these inputs. Whenever E is equal to 0, as this E is connected to all the AND gates, if any one of the input of AND gate is 0, then output of all AND gates are 0. So, here for example, E equal to 0, this 0 is connected to all the AND gates. If any one of the input of that AND gates is equal to 0, definitely the output will pull down to 0. Without knowing other inputs, the AND gates are providing 0. That is nothing but decoder disabled condition when enable equivalent to 0. This is 3 to 8 decoder we designed. For example, if you are taking any value like 111, so you are taking 111, here it will produce 000. So, which output you need to get means you need to get this 1 7 zeros you need to get. So, you are having 1 here. So, here you are having 1 and here this gate is connected to 0, here it is providing 0. So, here this gate is connected to 0, so that is why it is providing 0. Again this is also connected to 0, so providing 0. So, here itself this is connected to 0, so that is why this gate output is also 0 and here it is connected to 0, these two gates. So, these two gates outputs are also 0. So, see here also this is connected to 0. If any one of the input is 0 for the AND gate, the output is 0. So, in this condition only at first gate you are getting all ones for AND gate. So, you got 1 7 zeros. So, you got the same output. This is the design of 3 to 8 decoder. In the same way, you can design 4 to 16 decoders. You can take A, B, C, D and 4 to 16 decoder means 16 output lines you are having from Y15 to Y0. In the same way you will design, but the number of digits are varied for 3 to 8 to 4 to 16. The process is very similar to 3 to 8 decoder for 4 to 16 decoder.